Hello everyone, I am Dr. K. Muralidharan, Assistant Professor, Department of Science and Humanities, Dhaanish College, Dhaanish Institute of Technology, Coimbatore. Today we will learn the topic in probability, statistics and random process. The topic is stationary. So before we start the mathematical concept, we learn or we gain some basic concepts or examples in a real world applications and applying the ideas or concept and condition for triple S and double S. If triple S is strict sense stationary and WSS is wide sense stationary. Okay. So start the session. If stationary, start with a random variables. Random variable and the random process and stationary divided into two types. And first one is strict sense stationary and second one is W sense stationary. W sense stationary wide sense stationary. So random process, random variable is a numerical value in a random experiment, and random process a numerical value applied with time. Then it is denoted by x of t. Okay. And then stationary means if the time is not changed, then it is denoted by f of x of t. The function of x of t of x. This is denoted by the stationary. So here, strict sense stationary, that means WSS means a random process x of t satisfy two conditions. The first one is expected mean value is a constant, and second one is variance is a constant. Okay, if random process x of t is a QS, then first one is E of x of t, expected mean of random process is a constant, and second one is variance x of t is a constant. So now WSS means wide sense stationary, a random process x of t satisfies two conditions. The first one is E of x of t is a constant, that means expected mean is constant, and second one is Rx of t1 comma t2. Here Rx means autocorrelation. Autocorrelation is a function of t1 minus t2. Okay. So if that is why the random process with the two conditions, then the random process is known as a WSS. Okay. So now we will discuss one problem. If problem is show that a random process x of t equal to a cos omega t plus theta with an interval 0 to 2 pi. Okay, is that WSS? To be checked, the random process is WSS. Okay, here a and omega are constant, and theta is a uniformly distributed variable with the interval of 0 to 2 pi. Okay, so start the solution. So given problem, show that the random process x of t equal to a cos omega t plus theta. We check it is satisfied WSS. Okay, so solution. Again repeated the given values. Here given that x of t equal to some a cos omega t plus theta, and then theta is uniformly distributed. Okay, here theta is a uniformly distributed. Then the function value of theta, which means applying the uniformly distributed condition, that means 1 divided by upper limit minus lower limit. Then f of theta equal to 1 divided by, here apply upper limit is a 2 pi and lower limit is a 0. Then upper limit minus lower limit equal to 1 by 2 pi minus 0. Then finally we got f of theta equal to 1 by 2 pi. Okay. Now, so to given random process, x of t is a WSS. Already we know that the definition of WSS means first condition x of t is a constant, and second condition is autocorrelation is a function of t1 minus t2. Okay, so that is we have to find first value expected mean of x of t is a constant, and second value Rx is a function of t1 minus t2. Okay, so first one, to find expected mean value, that means E of x of t. Okay, so we know that the formula for expected mean E of x of t equal to integral over minus infinity to plus infinity, a random process x of t into the given function f theta into d theta. Okay, so replacing the values for x of t and f of theta in a given mean formula, we get a lower limit is 0 and upper limit is 2 pi. The integral over 0 to 2 pi, and x of t value is a cos omega t plus theta, and we find the value for f of theta is here f of theta is a 1 by 2 pi. Already we find it. Then into d theta. Okay, here take an outside from the constant value, we got a by 2 pi with the integral over 0 to 2 pi into cos omega t plus theta into d theta. We know that the formula, some integral over 0 to 2 pi cos of omega t plus n theta d theta equal to 0. So applying this formula in this step, we finally got some a divided by 2 pi into 0, which is equal to 0. Therefore, expected mean value is a constant. Okay. Your first step will be proved. So next step, to find the autocorrelation value Rx. Okay. So next step, to find Rx of t1 comma t2. So autocorrelation formula Rx of t1 comma t2 equal to expected mean of some x of t1 into x of t2. So here given random process x of t, replacing the t value, then x of t1 equal to some a cos omega t1 plus theta, and similarly x of t2 equal to a cos omega t2 plus theta, then some a cos omega t2 plus theta. So replacing x1 and x2 in a given autocorrelation formula, so we got an Rx equal to some expected mean of a cos omega t1 plus theta into a cos omega t2 plus theta. So we multiply the constant value a into a equal to a square, then take outside from the expected mean value So here we got an answer cos A into cos B time. So we apply the trigonometrical formula cos A into cos B equal to 1 by 2 times of cos of A plus B plus cos of A minus B. Okay. So here we take an A value is a first value some omega t1 plus b and b value is a omega t2 plus b. So now A plus B equal to adding both these values we got an omega is a common value of t1 and t2, then t1 plus t2 plus theta plus theta equal to 2 theta, then 2 times of theta. Okay, again A minus B equal to here neglecting the theta value we got an omega into t1 minus t2. Okay, so apply A B and A plus B and A minus B value in a given frame we get an autocorrelation Rx equal to some A square expected mean of some 1 by 2 times of cos of some omega into t1 plus t2 plus theta, so 2 theta plus cos of omega of t1 minus t2. So next step we multiply the A square value with the given expected B value or take out second 1 by 2, then A square divided by 1 by 2 into expected mean of first term and second term. So next step we split with both two terms, then we got A square divided by 1 by 2 into first value expected mean of cos omega t1 plus t2 plus 2 theta and second term A square divided by 1 by 2 A square divided by 2 into expected mean of cos of omega into t1 minus t2. So here we solve only first term because of this value is a constant. So now we find that expected of cos omega t1 plus t2 plus 2 theta. So applying the expected mean formula, the mean of x of t equal to integral over minus infinity to plus infinity x of t into f of theta d theta. So applying this formula in this step we got a same kind of result 0. Then here e of x of t is a 0. Then here e of cos omega t1 plus t2 into plus 2 theta is a 0 value. So replace this value in previous step. We got an autocorrelation Rx equal to A square divided by 2 into a first expected mean value is a 0 plus second value is a constant, then E of cos omega t1 minus t2. Okay, so we multiplied A square divided by 2 in a expected value. Finally we got a E expected mean of some cos of omega t1 minus t2. Okay, so this step will be the function of t1 minus t2. Therefore the given autocorrelation value is a function of in terms of t1 minus t2. Okay, here the first condition is expected mean is constant and second condition is r of x is the function of t1 minus t2. Okay, given random process satisfying the two conditions, then our random process x of t is a w sense stationary, that means white sense or weak sense w sense stationary means white sense or weak sense stationary. Okay, now I conclude this session. So today we will discuss on the topic for the stationary. If because of the random variable, random process, applying these conditions for stationary. The stationary has two kind of part. One is WSS and the second one is WSS. Okay, so first we solve the problem for WSS. That means white sense stationary regarding the problems. Okay, here I take the random process, then some A cos omega t plus theta. So now we check the values WSS. So it satisfies the two conditions. Then the given problem is